Hi, hello everyone. So we're kind of transitioning on from the coordinate geometry of the line to kind of its sister chapter, its sister theme, the coordinate geometry of the circle. So what you'll find is a lot of the stuff we used when we are doing the line will bleed into cross-pollinate, whichever we want to call it, the circle bit. So we're going to get cracking on it, and I'll do a bit of background, a bit of theory that'll make a bit more sense as we kind of move into it. I won't be doing this quite often in terms of drawing, but I just for the start, I'm just going to draw a little XY axis just to kind of visualize what we're going to be doing. Now, it's not necessary. So it's an XY axis. There's 0, 0 coordinate right there in the center. Okay, so let's pop in some 1, 2, 3, 4, -1, -2, -3, -4. Okay, now we'll go up and down a bit. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, might as well go to 5 on everything. There's 5 there. Okay, there's 5 there. So a simple enough coordinate geometry type of situation. So I'm going to draw a circle where the center is 0, 0. You don't have to do this. I'm just doing this for theory. And it has a radius of 5. So I'm going to go out to 5. Okay. And it, as predicted, it crossed at 5 on each of them. Okay. So it has a radius of 5. Okay. Diameter of 10, radius of 5. Nothing crazy or new there. Okay. But, and this is where it gets really cool. Okay. This is where if I draw any, use different color, okay, any line that touches the edge of the circle from the center, that is a radius. Okay. Now, how can you find the radius just using geometry? I hear you cry. Well, it's pretty simple. It's just, let's do this in parts. Okay. The other two sides squared and added together gives you this side squared. Would that not be true? So in other words, if this is a certain amount of x and this is a certain amount of y on the y-axis, okay, to give you an x, y coordinate up here, then it would be true to say that x squared plus y squared equals r squared. That would also be true. Would you see what I mean? And this, would you believe, is the equation of a circle with a 0, 0 center. Okay, it will have a center of 0, 0 and a radius of r. So that's the way it would work. Okay, so I'm going to show you this in a few different ways. Okay, so over here we'll have a look. Diddly I do. So let's say I give you a equation like this. So remember, our generic equation is x squared plus y squared is equal to r squared. So what can I tell about this? Well, I can tell that it has a center of 0, 0 because it's in that form. And it has a radius equal to, well, if that's the radius squared, well, then it's the square root of 36, which is 6. So straight away, once it's in that form, you can work it out. So we'll try another one. So that's 1. Let's try another one. Again, this form is in your log table, so need to remember it. Okay, x squared plus y squared is equal to 50. Okay, so we have a center of 0, 0. And we have a radius of the square root of 50. Okay, you can put that into your calculator to let it do the heavy lifting, but that's 5 root 2. Okay, I'll check. Square root of 50, 5 root 2. Sorry. There it is, 5 root 2. Okay, I always try and put it in third form as opposed to square root 50 form. Okay. There's two little examples done. Now let's try a third one. Okay, let's kick it up a notch. Now you're thinking, ooh, wait a second, sir. No, something's gone wrong here. Has to be in the form of x squared plus y squared equals r squared. But that's not x squared. That's 4x squared plus 4y squared. Well, don't worry. Plus y squared is equal to 49 over 4. So now it's in the form of what you want. And then we just do our usual. The center is 0, 0, because now it's an x squared plus y squared form. What's the square root of 49 over 4? Well, square root of 49 is 7. The square root of 4 is 2. So it's whatever, 3.5. Okay, but I leave it in fraction form because you know what I like. I like fractions. So there is a tougher example of it. Okay. So you can see you could be asked to do anything here, lads. You could be given this and asked to draw on it. It could be drawn, and it could be drawn, and you could be asked to convert it into this type of form. You could be given this point and asked to get the length of that using your square root of x2 minus x1 to be squared, y2 minus y1 to be squared, and then convert it into that. There's lots of different things you could be asked to do. You could even be asked to, and we will do this one because I think this one is cool. So I'm going to draw a circle. I think this one's pretty cool. So the center of that circle is 0, 0. Okay. And this is where it gets really cool and nifty. I'm just going to randomly put a point. Let's do it over here. Why not? And we're going to draw a line that touches at that point. Okay. So let's give this line an equation. Okay. Let's call 2x plus 3y equal to 13. Okay. And the question to you is, can you give me the equation of this circle? So remember, circle has to be in the form of x squared plus y squared is equal to r squared. I have my x squared plus y squared bit, 0, 0. But how do I find the radius? I don't have any information. Or do I? Let's think about it. Think back to our previous chapter. Okay. What do we know about tangents? A tangent is a point that touches a circle once and only once. And we also know from your junior cert that if you draw a line from a tangent where it touches a circle right back to the center of that circle, it does something really special. It creates a right angle. Now, what did we do in the previous chapter that would allow us to find that length? Yes, I hear you shout. We use the perpendicular distance formula. Do you remember it? The perpendicular distance. This is where you need to use your cross-pollination. What other pieces of information do you know from previous chapter, especially the line chapter? And this works both ways. That will help you in the circle chapter. There's stuff in the circle chapter that will help you with the line stuff and vice versa. So this is where you have to be super careful. But anyway, let's have a look at it. What is the distance formula? Isn't it just ax1 plus by1 plus c over square root a squared plus b squared, where a and b are the coefficients of the x and y and c is the constant, that type of thing. Okay, so let's put in everything we know. This is A, this is B. We're going to bring him back in to make him C. So C is going to be minus 13 when we bring that one back in. Okay, so just be careful of that. Depends which form it's put into. So let's put them all in and we see what we're going to get. Okay, we need an x1 and y1. Well, an x1 and y1 is going to be easy. It's going to be 0 and 0. Okay, there's your x1 and your y1. So let's pop them all into this formula. So we have the absolute value of a 2 times 0 plus 3 times 0 minus 13 all over the square root of 2 squared plus 3 squared. So that's minus 13 over what's going to be absolute value. So it's going to be 13 over the square root of 13. Okay, so what's 13 over the square root of 13? Well, listen, if you don't know, you can always multiply top and bottom by square root of 13. Okay, to kind of work it out. Okay, so let's work it out on the calculator because life's too short. Root 13. It's root 13. Okay, so it's actually root 13. So that means x squared plus y squared equal to r squared. If r is root 13, then x squared plus y squared is equal to 13 because you're squaring square root of 13. So there's an example of a cross-pollination between simple enough situation of a line touching. So that's quite a popular one, in fairness. Let's try another one. And again, another nice one for you to try. Okay, so I draw a nice pretty little circle. Okay, and I'm going to draw a tangent. Pick a point. Let's pick one down here. Okay, so there's a point down there. There's the center, 0, 0. Okay, so this time, okay, let's make this one a bit more interesting. Okay, this time, let's work backwards. Okay, let's find, we'll give you this point to start with. It's down in this quarter, so let's say it's -2, -3. Okay, and I want the equation of the circle. So how do I do it? Well, let's start with what we need. We know we need it in this form. Now we already have the x squared and y squared. It's there. It's 0, 0. But how do I get the r squared? That means I need this line. I need this line. This is r. So we can use our straightforward method here because we have 0 and 0, and we have -2 and 3. We can just use our distance formula. And we just go square root x2 minus x1 to be squared plus y2 minus y1 to be squared. It's the same thing again, square root of 13. So r is equal to the square root of 13, which means r squared is 13. So it's x squared plus y squared is equal to 13 is the equation that you're looking for. Now, let's have a bit of fun with this, okay? So I like having fun. Imagine for a second that out here, there's another line. Let's call that L1, L2. Okay? So L2 is out here. What do you think the point is there? Okay? That's the first thing I want you to figure out. And if you can find that point there, would it be possible to get the equations of both slopes? Of both tangents. So let's kind of brainstorm this one for a second. Okay? That distance from there to there is also the same distance from there to there because they're radii. Okay? A tangent can only touch one point, and the center to that is a radii. Okay? So whatever distance that is, and they're parallel, is going to be the same distance in. So -2 and 3 goes to 0 and 0 goes to, so we're just using the translation. What's the translation? What's going to give me that point? Well, what am I doing here? I'm adding 2. What am I doing there? And taking away 3. Okay, so that's 2 and -3 straight away. Okay, now we need a slope. And what's the slope of this one? Because it's going to be the same slope as this one. The slope of that line is going to be 0 and 0 and -2 and -3, x1, y1, x2, y2. y2 minus y1 over x2 minus x1. So it's going to be 3 over 2. So the slope of this, the problem is we want the slopes of them. So it's perpendicular, isn't it? So that's perpendicular makes it -2 over 3. So now I know that that's a point, and I put as -2 over 3. That's a point, and it's going to have the same slope, -2 over 3. So then now it just becomes a very simple y minus y1 job to get the formula. So let's do it very quickly. So we'll take the top one, L2. So L2, we have y2, y minus y1, m on x minus x1. Okay, so that's going to be distribute the 3. So that's 3y plus 9 minus 2x plus 4. So that's 2x plus 3y. What do we got here? Plus 5. So that's L2. Okay. So then, sorry, this is all over the shop, but I'm just, you know, I like when I get into this kind of zone where I'm really excited about the maths, I just go all over the shop with it. So that's L2. How do we find L1? Well, we know it's going to have the same 2x plus 3y, but what's the constant? That's really what we're going to have to. You could figure it out pretty easily. Okay, so let's predict it. Minus 4 and minus 9. Minus 4 is minus 13. It's going to be plus 13. We'll give it a go anyway. So I can do it here. L1, we're going to have y minus y1 is equal to m on x minus x1. Okay. Right. So distribute 3y plus 9 is equal to minus 2x minus 4. Yeah, I was right. 2x plus 3y plus 13 equals 0. And that's that one done. So you can see they're exactly the same except the 5 and 13. Happy days. Okay, so there's a little introduction into coordinate geometry of the circle. Used a lot of the line stuff. You can see this, lads, but you know, it's pretty cool stuff. Okay, thank you very much. Goodbye.